Okay, so we left off with we identified the sample mean. We identified the sample standard deviation. We said we didn't have the population standard deviation, so it's t. The sample was 40, and we have to do a 98% confidence interval. Okay. So the true mean GPA for students at Central High School, that is the population parameter. That's the population parameter. Population parameter always starts true mean, true proportion, always starts that. Okay. Um, and then the test statistic we're going to use is the T. Okay. Next thing we have to do is conditions assumptions. All right. So let's see. Conditions. Okay, so conditions, and we have to check them since it came from a sample. So SRS, 10% condition, and then is shape approximately normal. Okay. Okay, so SRS. Let's see. It actually says an SRS of 40. So that one's stated. Okay. 10% condition. N is less than or equal to 10% of big N. So 40 less than or equal to 10%. I don't have a number there, but it would be all CHS students. So there would have to be at least 400 students, and there are. Okay. This is where on the quiz, some of you, the third one was the big condition number 1 and number 2. You guys are pretty good at. Not a lot of problems with those. Everyone got their full credit. Number 3 is where you guys kind of veered off a little bit. And it's common. It's very common. It's not just you guys. It's I see it every year. Remember, number 3, there's 2 different ways you can go. If it's proportions, n times p is greater than or equal to 10. N times 1 minus p is greater than or equal to 10, right? If it's means, we're going to use one of these guys here in red. It's not red on yours, but still in here. Okay? So just be careful. Some of you tried to use essential limit theorem when it was a proportions question. Some of you tried to use n times p greater than or equal to 10 when it was a means question. So just for the next test we take, because this quiz was 25 points, so quarter of a test, right? It's the only assessment we have in the grade book, so it affects your grade. But in the long scheme, in the end run, it's not going to be that big of a deal. Okay, the next test we take will be 100 points, 4 times what you just took on the quiz. Okay, so you can retake it, but what I would do is wait until you take chapter 8, because chapter 7 and chapter 8 are very much intertwined. A lot of the stuff we talked about in chapter 7, we're still talking about in chapter 8, right? We're still doing a lot of the same stuff. So if you do well on chapter 8, you might not need to retake the test, to retake the quiz, but you can if you want. Like I said, you can if you want. Okay. Because like I said, the test that we take eventually for chapter 8, probably end of next week, will be 100 points. Okay. Will be 100 points. So 4 times what the quiz was. All right. Anyway, got off track there. So we have one of these 3 options, right? They state that population is normal. Nothing in the question about that, right? Nothing in the question was said GPAs or population, the GPAs are normally distributed, okay? Sample size is large enough. Well, yeah, we had a sample size of 40, so I think number 2 is going to be our condition check here, okay? Since sample size is greater than 30, n equals 40, shape is approximately normal due to central limit theorem. Okay. All right. That one's done. So now next one is calculations. So we're going to use the formula that we just stated up here. X bar plus or minus T critical. X bar is our sample mean. That was 2.98. Plus or minus. T critical. What is T critical going to be for this question? How do we find T critical? That's my question. We need to find degrees of freedom. Good. So for this question here, what is degrees of freedom going to be? 39, right? 40 minus 1 or 39. Okay. So we have 39 degrees of freedom. Okay, so let's go to my chart. There is no 39, but 40 is the closest, so we're going to use the row that says 40. And then, let me see, let me highlight that. What percent confidence interval was it? 98. So we're going to go where those meet. 2.423. 2.423. Times standard deviation of the sample, which was 0.54. Since we don't have the population standard deviation, we use the sample divided by the square root of 40. Okay. So then we just got to crunch some numbers. So my margin of error I get is 0.2069. Okay. So we're going to add those two numbers and subtract those two numbers to come up with our interval. Okay, so 2 plus 2.98. So when I add them, I get 3.187. And when I subtract them, I get 2.773. Again, the calculator is able to do it faster. I'll show you right after this problem. I'll show you how to calculate. It's kind of like how we did for proportions. The calculator can calculate those quicker. I'll show you right after we're done with this problem. I'll show you on the calculator. Okay, but it's not hard, especially when you have a calculator. You just I do the parentheses first, and then multiply, and then add and subtract. Okay. Okay. So last thing is conclusion. Using the sentence frame we used last week, We are 98% confident that the true mean, this is where your population parameter is going to come in, true mean GPA for students at Central High School is between 2.773 and 3.187. Okay. I underline the parts that are the sentence frame parts. Okay. You don't have to do that, but since it's your notes, that's what I did. Every time you have a conclusion, it's going to be we are blank percent confident that the true proportion or true mean blank is between this and that. Okay. All right. That was part A. Part A was that answered part A. Part B says a brochure was given to prospective 8th graders that says that the average GPA is actually, so there's a claim. The claim is that the GPA is 3.15. That's the average GPA. Do we have sufficient evidence to change the brochure? In other words, do we have sufficient evidence to say, nope, that's wrong? Do we have sufficient evidence to say that this claim right here is wrong? Well, we don't know if it's wrong or not, but all we're asking is, do we have sufficient evidence to say, nope, wrong? Because it's within the interval, exactly. So this is where it's important. We never say you're right. We never say you're right. All we say is we don't have enough evidence or sufficient evidence to say you're wrong. So we don't have enough evidence because the true answer, I'm 98% confident that the true answer is between here and here, right? I'm not 100% confident, right? And that's still a pretty big gap. It's from a B minus or a C plus to a B minus, right? That's close, but still, so there's still some leeway. So that's why we never say you're right. We always say we don't, we either say we have enough evidence to say you're wrong, or we don't have enough evidence to say you're wrong. We never say you're right. Okay. So to answer that question, I would be like, there is not sufficient evidence to deny the claim, or there is not sufficient evidence to say the claim is incorrect because 3.15 is within the interval. Okay. So let me see. We do not have sufficient evidence to dispute or refute the claim because 3.15 is within the interval. Okay. So all that's saying is I don't have enough information. I don't have enough information to say the claim is wrong. I never say the claim is right. It's like court, right? We talked about this last week. You either have enough information to say they're guilty, or you don't have enough information, so you say not guilty, right? We never say innocent, right? We never say they didn't do it. We just say there's not enough evidence to show that they did it. It's the same thing. Anytime there's a claim, we either say, yeah, we have enough evidence to show that's not right. It's wrong. What is the right answer? I don't know, but that's not right. Or we say we don't have enough evidence to say it's wrong. That's it. Okay. So in this case, we don't have enough evidence because 3.15 GPA is within the interval. Okay. So just be careful with that wording because I'll have some people say, yeah, they're right. 3.15 is the true GPA. It could be, it couldn't be. I don't know. I don't know. That's not what I'm doing. Right. I'm not, I'm just trying to estimate the true parameter. I don't know for exact. Okay. All right. Okay. What I want you to do now is do example number 3. Mhm. Yeah, go ahead. Do example number 3, A and B. Okay. So, in the previous section, you learned 73% of all American adults, claim to have read a book in the previous 12 months. This was based off a 2016 Pew Research study that interviewed a random sample of 1,520 American adults. The same study reported the average number of books read by members of the sample was on average 12. That includes the people who didn't read anything. Okay, so that's all 1,520. Standard deviation of 18 books. Okay, so construct and interpret a 95% confidence interval for the mean number of books read by all Americans in the previous 12 months. So right there in yellow, I highlighted, that's going to be my population parameter. The true mean number of books read by all Americans in the previous 12 months. That's what my interval is going to estimate. Okay? Test statistic. Well, this is T because I don't know population standard deviation. I just know the sample standard deviation, which was 18. I don't know population. I don't know the standard deviation for all Americans. I only know for the 1,520 that were in the sample. Okay. So because of that, my test statistic is X bar plus or minus T critical times S divided by the square root of N. Okay. So you're going to get a point for each one of these. So it doesn't matter if these seem redundant. Okay. If you want to get full credit, you need each of those 5 parts. Okay. So make sure that you, especially the test statistic, a lot of people forget this. They're like, oh, well, I used it. Why do I have to write it? You have to identify which interval you're using, what type of interval. Okay. A T interval. Okay. Okay. So conditions. Sample size is big enough. Okay, make sure those are done too. You guys did a good job of taking up some space when you did these. As the chapters go on, I find that this becomes smaller and smaller on your paper. Don't let it become smaller and smaller. This is worth as much as anything else on here, right? Some people think conditions, oh, why do I have to do conditions? It doesn't matter. You get credit for it. Okay, so it's worth just as much as your calculations or your conclusion. Okay, so it's important. All right. Okay, so calculations. Degrees of freedom was 1,519. I don't have that. The closest one with us out was 1,000. We're never, ever, ever going to use the infinite one because we're never going to get close to infinity. 1,000 is always going to be closer. So I don't care if our sample was in the millions. We'd still use 1,000. You wouldn't use infinity. If you want to use infinity, that's Z. Those are Z, which is on the other side. Okay. All right. We are blank percent confident, 95% confident that the true mean number of books read by all Americans in the previous 12 months is somewhere between 11 and 13 books around. 11.094 and 12.906. So somewhere between 11 and 13 books, the average American has read. That's what that's saying. I'm 95% confident in that. Okay, and there's the fifth point for credit. All right, very last thing. Let's see. Pew reported that American adults read an average of 14 books in the previous 12 months. That was their claim in 2011. Okay. Does your interval from part A provide convincing evidence that it's different? So, pretty much, can we refute their claim? Last one, we couldn't refute their claim. Were they right? I don't know, but we just couldn't. This one, can we refute their claim and say that number is not correct?
Yes.
Yes, because exactly. So this one we do have sufficient evidence. We do have sufficient convincing evidence to say that that 2011 claim is wrong because it's outside of our interval. Okay? So we can say we do have enough evidence to say they're wrong. Okay? All right. Okay. So let's see here. Tomorrow, I'll give you some time to do some practice. Okay? Tomorrow, we might do the last practice problem. I'm not sure. Yeah, we'll probably do that. First thing we do is probably do example number 4, and then the rest of the time I'll give you to start on your assignment like I did previously. And that's the end of the chapter. That is the end of chapter 8. Okay? Mm-hmm.
So for the chapter test, I was wondering, could I take that during calculus?
That's fine.